Hi everyone. Today is Wednesday, February 8th. So today we will finish 1.6 and start 1.6. This Friday you have your homework 3 and you have your first quiz. Okay, so your quiz 1 will have 2 problems and then you have answer those questions. Usually it has 2 or 3 questions. Depends on the difficulty of the questions. Okay, so remember on the Friday, you have the whole day to start your quiz anytime. And once you start it, you must submit your answer within 30 minutes. Okay, so my recommendation is use your laptop to open the quiz in Blackboard. And then you look at the problems and write down your solution on a piece of paper. And then take pictures, convert into a PDF. And then email to yourself. And then use your laptop to upload this PDF to Blackboard and submit. Is that clear, everybody? Okay. And don't submit HEIC file. My laptop doesn't have this app to open it. Okay? Please submit PDF. And sometimes because of the internet connectivity issue, if you accidentally log out, I have changed the setting to unlimited attempts. So if you get logged out in the first attempt, open a second attempt right away and then submit your PDF. But if you use more than one attempt, you have to email me and explain to me why. Okay, everybody? All right. So that's the quiz. And so let's continue to talk about session 1.6. So we were solving equations, right? We talk about polynomial equations. But then we move all the terms to the left-hand side, and then we try to factor. Do you remember that? So for those of you who missed class, please make sure you watch the recording and take notes. If you have questions, ask me. Okay, don't wait. Ask me. And it's also good to schedule a tutor. Do you know we have free tutoring services in the OSS? You can schedule to meet a tutor weekly. So come to see me and meet the tutor and do all we can do to do well in this course. How many of you want to get A in this course? Everybody? Everybody? Yes, let's go for it. And then when we solve equations involving rational expressions, here are the steps, right? We first find the LCD, the least common denominator, and we do the domain. The domain is a possible x value such that the expression makes sense. And we set the denominator not equal to 0. And then we combine the rational expressions. So all the terms has a least common denominator. And then we multiply the least common denominator to clear all the denominators. We get a polynomial equation, right? Then, how to solve polynomial equations? Move all terms to one-hand side and factor, right, everybody? And finally, because the domain is not all real numbers, so we have to check. So make sure our answers is in the domain. Okay, everybody? All right. And then this was example 3. We did this example, and you can see we found 2 solutions. And we need to check the domain. Therefore, the domain x cannot be 3, x cannot be -3. So 3 is not a solution. We can only take x equals to -1. Do you remember this problem? So we have to check the domain. This is very important. All right. How about radical expressions? Radical expressions, also the domain. We need the things inside the square root to be greater or equal to 0. You cannot have square root of negative number because that is complex number. That is not a real number. Right, everybody? So the step is isolate one square root term. Okay, you have two square root terms. It's okay. Do it one by one. Isolate one of them. Isolate means you have that square root term on one side by itself. Right, everybody? So move all the other constants to the other side. So this is what we did. We moved this term to the other side. So this one square root term is isolated. Then square both sides to carry out that. And in this process, you're gonna use this formula, the complete square formula. A plus b squared is a squared plus 2ab plus b squared. Common mistake is students forget about the 2ab. Remember, when you have square, if you have sum or difference, can you distribute the square? No. You can only distribute the square if you have product or division. Right? When you have sum or difference, it's not equal to that. And we already know that many times a squared plus b squared cannot be factored. Right? A squared minus b squared is a plus b times a minus b. Right? Everybody? Okay, if you're not familiar with the formula, write it down on a piece of paper and tape it on your restroom door. Okay? So please do it tonight. Okay? And in the future, I sometimes pick some of you to answer, hey, what's the formula of the difference of squares? Okay, I will tackle you. All right. So we complete the square and expand it, right? And simplify. This square and this square root cancel. But we still have one square root. Therefore, isolate the square root term. Okay? Isolate it, and then we can square both sides again. Then find the x. Because here, square roots, radical expressions, the domain is not all real numbers. So we have to check. Okay? So plug in this term and plug in this term and see if the left-hand side equals the right-hand side. Do you remember this problem last time? If you weren't here last time, make sure you watch the recordings. And please do this exercise at home. Okay? My website has the solution. Yes, the notes with the answers. I have solution for it. Okay, so you can check your answers with the notes with answers on the website. And then last time, we also did this one, right? This one is similar to the one we did. We have two square root expressions, so we have to get rid of them one by one. How do we get rid of them? Isolate one of them and square both sides, right? So we square both sides here, complete square, expand it, and then combine the like terms, right? And we have one. We still have one square root term. Isolate it. But in this process, do you like fractions? No, right? Therefore, like this step, all the terms has a common factor 2. We divide it by 2, but only divide by 2, not divided by 4, because you don't want to have 1/2 and 5/2, right? Everybody, we don't like to work with fractions. Therefore, leave the 2 here. But when you do the square on both sides, don't forget that 2 becomes 4. Right, everybody? And then this one, we need to expand it. That's why the formula is very, very important. You use it a lot. And then you combine the like terms, you get a quadratic equation. So you either do the factoring or you can do the quadratic formula. And then we got 2 solutions. Last time, we just put it in, right? And then, oh, it looks like it works. But actually, that is not enough. So I want to show you this example. Just plotting in it is not enough. We actually need to verify if the left-hand side equals the right-hand side. So okay, so that is wrong. Okay, why? because we actually need to plug in. So we need to plug in the original equation and make sure the left hand side equals the right hand side. Okay, let's see. If x equals 11, here we get 2 times 11 plus 3. We plug in minus 2 times square root of, oh, I don't have enough space. Okay, 11 minus 2. This is the left hand side. We want to ask, is it equal to 1? Right, everybody? We are putting in the original equation. What's 2 times 11? 22 plus 3? 25. Square root of 25 is 5. And then 11 minus 2? 9. Square root of 9? 3. What's 2 times 3? 6. 5 minus 6? Negative 1. Is negative 1 equals to 1? Oh, see? 11 is not a root. Okay? So just checking in the square root, checking in the domain is not enough. We actually need to plug in the original equation and verify if the left hand side equals the right hand side. Okay, everybody? Mm-hmm. Check the other solution. How about x equals 3? And then we have 2 times, replace x by 3. Replace x by 3. We want to ask, is the left hand side equals the right hand side? What's 2 times 3? That is 6 plus 3. 9 square root of 9. 3. And then 3 minus 2? 1. 2 times 1 is 1. Oh, is 3 minus 2 equal to 1? Yes. See? So the solution is only x equals 3. So we only have one solution. Okay, everybody? So this is how we solve equations involving radical expression. Yes. Gotta check the domain because not all of them are solutions. Okay. So that is example 6. Let's continue on the absolute value equation. All right. So remember the definition of the absolute value of x. So what is absolute value of x? We have the real number line, and that is the 0. And then x is right here. Absolute value of x is the distance between x and 0. And then you know distance is always positive or 0. It won't be negative, right? Therefore, the absolute value of x is always greater or equal to 0. Yes, everybody? Absolute value, always greater or equal to 0. And how do we break the absolute value? Well, it depends, right? We have to separate into two cases. If x is greater or equal to 0, then absolute value of x is x. Because x is greater or equal to 0. Right, everybody? So it's okay to just let it be x. But if x is negative, well, because x is negative, then minus x will be positive. So absolute value of x will be minus x. Okay, everybody? This is how we break the absolute value. Example. What's absolute value of 2? 2. What's absolute value of negative 2? 2. But you can think of 2 as negative 2. Right? Negative, make it positive. This is the same idea here. Because if x is negative, then negative x will be positive. So absolute value of x equals negative x. This is how we break it. Okay, everybody? Mm-hmm.
So the absolute value of x can be positive x and negative x?
Yes, it depends on the x. But in any cases, absolute value of x is always greater or equal to 0. Yes. Okay. So yeah, therefore, if absolute value of x equals to a, then x equals to a, or x equals minus a, right? Okay. If I say, oh, absolute value of x is 5, your x could be 5 or negative 5, right? Everybody? Okay. To solve absolute value equations, remember, isolate the absolute value first. And remember to check if the solutions are possible. This is very important because the variable also occur outside of the absolute value sign. Okay. All right, so how do we do it? Okay. Keep in mind, if absolute value of x equals to a, that means we either have x equals a or x equals negative a. Therefore, when you solve equations involving absolute value, put a line there because we want to break them. We have two possibilities. Okay? The first one, absolute value of x is a. The first case, we have x equals to a. Okay? In this case, it's kind of, we just forget about the absolute value. Okay, so here, kind of ignore the absolute value. So you get 4, ignore the absolute value, but then replace it by parentheses. Okay, so 4 times x minus 2. Okay, maybe let me write down, replace by parentheses. Plus 1 equals 3x minus 3. Okay, so this is the first one. Just break the absolute value, just ignore it, replace it by the parentheses. And then solve for x. Ooh, do you see? We can distribute the 4, right? We get what? 4 times x is 4x. 4 times negative 2 is negative 4 times 8. And plus 1 equals 3x minus 3. Right? Combine the like terms. What is negative 8 plus 1? Yeah, negative 7. And let's combine them. How do you combine the x? What do you do to it? Yeah, subtract 3x on both sides. And what's your left hand side? X. Oh, what do you do to the constant? Add 3, add 7, right? Yes. Then we get x equals what? Negative 3 plus 7 is 4. Right, everybody? Okay. So this is the first case. Just the absolute value of x minus 2 is x minus 2. Okay. And let's do the second case. And then we do the check finally. Okay. So second one is replace. So replace absolute value by negative of that. Wow, this is using absolute value of x. It could be negative of negative x. Right, everybody? Therefore, so this one corresponds to just ignore the absolute value. So x becomes x. And then here, replace the absolute value by negative x. So negative of whatever inside the absolute value. Okay? So therefore, we get 4 times. negative of x minus 2. Okay, be careful. This is 4 times. It's not 4 minus. Okay, everybody? This is 4 times. Typical mistake. If you just put 4 minus, then it will be wrong. We need multiplication. Plus 1 equals 3x minus 3. All right, let's see. 4 times negative 1 is negative 4. When you distribute, we get what? Yeah, very good. That's 3x minus 3. So far, so good, everybody? Combine the like terms. Oh, what is 8 plus 1? 9. Right. Okay, how can we combine the x? Add 4x on both sides. Right? Then we get 7x minus 3 equals 9. How do we combine the constant term? Add 3. Right? We get 7x equals, what's 9 add 3? 12. Yes, 12. So what is x? 12 over 7. Right? Now, we have two solutions. We need to check. So when we check, we plug in the original equation and see if the left-hand side equals the right-hand side. Right, anybody? Okay, so here, 4 times absolute value, x is 4, minus 2 plus 1 equals, is it equal to 3 times x? X is 4, minus 3. How about you guys take turns to answer my question? How about this time we start with this side? Hi. What is 4 minus 2? 2 times 4. 8. 8 plus 1. 9. So the left hand side is 9. Next student. Oh, hi. Yeah. What's the right hand side? 3 times 4. 3 times 4 is, yeah, you. Yes. So we will take turns to answer the question. So let's see. Let's follow this pattern. So it's finished you and then you guys and then that side. Okay. So 12, right? And 12 minus 3. Can you see it? 12 minus 3 is. So we're talking 9, right? Are you able to see the board?
I can see this one.
Oh, okay. Yes. So we're right here. We're putting in the original equation and see if the left hand side equals the right. The 12 minus 3. It's also 9, right? Check. Yes. We have the left hand side equals the right hand side. So yes, this is a solution. Now, how about the other one? So we check. We plug in the original equations. We get x. X is 12 over 7. We want to ask, is this equal to the right-hand side? This is harder because we have rational numbers. Hey, hi. Do you know what's 12 over 7 minus 2? Happy fractions. Yes. We all hate it. So let's take the common denominator. What's the common denominator? 7, right? So 12 minus 2 is what over 7? 14, exactly. Oh, what is 12 minus 14? Negative 2. Ooh, negative 2 over 7. What does the x value do to it? Turns to positive. Wow, so we return to positive. We get 2 over 7. Okay, this is 2 over 7. What's 4 times 2 over 7? How about you? 8 over 7. 8 over 7 plus 1. What's that? Yeah, that is 15 over 7. That's the left hand side. We want to ask, is it equal to the right hand side? Hi, what's 3 times 12? Yes, 36 over 7 minus 3. 3 is what over 7? Yes, 3 is what over 7? What's 3 times 7? 21, right? So 3 is 21 over 7. Right, everybody? Okay, what's 36 minus 21? 15. Ooh, is the left hand side equal to the right hand side? Yes. So check. Both of them are solutions to this equation. Questions?
So on like the first one,
Mm-hmm.
you took like minus 3x from the right side.
Yes.
And then on the second one, you took 4x on the left side.
Oh, that is because I want to make the coefficient of x to be positive. So there are so many ways to solve equations, but my habit will be I want to do the operation so that the coefficient of x is positive. For equation, it doesn't matter whether the coefficient is positive or negative, but for inequality. So next section, we'll learn inequality. When we multiply or divide it by a positive number, the inequality sign won't change. But when we multiply or divide it by a negative number, it will flip the inequality. That's why my suggestion is try to have positive coefficients for the x. Because eventually when you solve for x, you still need to divide it by the coefficient. If it's negative, when you work with inequality, you have to put the sign. If you forget to put the sign, and then it will be wrong. Okay, everybody? I'm just suggesting this way to reduce the chance of making mistakes. Okay, so this is how we solve equation involving absolute value. Just break it. Okay, let's increase the difficulty. So here, the power of x is just 1, right? Part B, do you see the power of x is 2? We get quadratic. But the method is similar. Okay, so put a line there. The first one, you kind of just ignore the absolute value, right, everybody? So we have x squared minus 3x equals negative 4x plus 6. Right, everybody? We want to, this is polynomial equation. We want to move all the terms to one side, right? Okay, let me ask next student. Hi. If we want to move these to the other side, what do we do to the 4x? Yeah, we add 4x. Can I also move the 6 to the other side? What do we do to get rid of the 6? Subtract it. Is that okay? I do both of them in one step? Yeah? Okay, can you tell me what's on the left-hand side now? X squared.
Plus x minus 6.
Thank you. Okay, good. Wow, this is This one is easy, right? We can factor it. But I told you in the exams, you might have harder to order the equations. So practice factoring. If you cannot factor, use quadratic formula. Okay, hi. How do you factor it? Very good. X plus 3 and x minus 2. Sorry, x minus 2. Okay. Then we have multiply the outer terms, we get negative 2x. Multiply the inner terms, we get 3x. And we add them, we get x. Okay, great. We have product of two factors equal to 0. We just set them equal to 0. Mm-hmm. So set them equal to 0. X plus 3 is 0. Or x minus 2 is 0. What is x? Negative 3. And then here, positive 2. Ooh, we get two solutions. Okay, that's the first one. And let's find all the solution and then we check at the very last step. Okay, this one we replace absolute value by negative parentheses. And then the other stuff remain the same. Is everybody okay with that? We replace absolute value by negative parentheses. Okay, next students. We break the parentheses, what do we get?
Negative x squared plus 3x.
Thank you. Okay, questions. Do we want to move these terms to the left or move this term to the right? To the right. Why? Coefficient of x squared will be positive. Can everybody see that? Mm-hmm. When we move, hey, if you move this thing to the left, your coefficient is still minus x squared. But if you move this to the other side, the negative x squared becomes positive x squared. That is why we want to move to the right side. Okay? So, who's next? What do we do to the x squared? We add x squared. What do we do to the 3x? Subtract 3x. So your left hand side is 0. What's your right hand side? Who's next? Yes.
The right hand side is x squared minus 7x plus 6.
Mm-hmm. Yes, very good. Can we factor them? Next student. How do we factor them? What are factors of 6? 3 and 2, and also 1 and 6, right? Which combination gives you 7? Think about 3 and 2. When you add them, 3 plus 2 is 5. When you subtract them, 3 minus 2 is 1. So it won't give you 7, right? How about 6 and 1? Yes. Oh, but it's minus. So you need minus 1. Yes. Okay. Minus 1 and minus 6. Good. We set each factor equals 0. So what is x? 1 or 6? See, we have 4 solutions. We need to check all 4 of them. Okay, let's do it one by one. Check. Okay. For x equals negative 3, we plug in. So we get what? Negative 3 squared minus 3 times negative 3. And is it equals to negative 4 times negative 3? Oh, I don't have enough space. and then plus 6. Okay, next students. Negative 3 squared is 9. Negative 3 times negative 3, huh? 9. 9 plus 9, 18. So the left hand side is 18, right? So, okay, left hand side is 18. Next student. What is negative 4 times negative 3? 12. 12 plus 6. 18. Ooh! Do you see we have 18 equals 18? Yes. X equals minus 3 is the solution. Let's check the other one. X equals to 2. We plug in 2 squared. Everybody okay for plugging in, right? Whenever we see x, replace it with 2. So 2 squared minus 3 times 2 is it equal to negative 4 times 2 plus 6. And let's see, next student. Hi. What's 2 squared? 3 times 2. 4 minus 6. Negative 2. Oh, absolute value of negative 2. 2. Is it equal to the right hand side? Hi. Negative 4 times 2. Plus 6. Negative 2. Oh, is the left hand side equal to the right hand side? No. So this is not a solution. Oh, not all of them are solutions. By the way, this problem is so nice, and we get integers for both cases. But in general, it's hard to make a problem look such nice. So you expect in the exams, your quadratic equation, you might not get a nice number, then you plug into your calculator. Okay, so you can use your calculator. Okay, how about here? So when x equals to 1, we get 1 squared minus 3 times 1. Is it equal to negative 4 times 1 plus 6? Yeah, this is negative. Huh? Negative? Oh, here? Where? It's negative? Oh, right. Okay, when we plug it, don't plug in this one. We plug into the original equation. The origin has to be original. Because when we break it, it could be true, it could be false. We don't know which one is true. Because if the things inside the absolute value is positive, then we're using 1. If the things inside the absolute value is negative, then we're using this one. So we don't know which one is true, okay? That's why we will check it, plug into the original one. Okay, so if you plug in this one, then it's always true. Yes, you can see if you put this in this one, always true. And that's why it doesn't help. Plug in the original one. Yes, good question. Okay, 1 minus 3 is negative 2, and but absolute value, so it becomes 2. Look at the right hand side. Minus 4 plus 6. Yeah, so check. Okay, last one, 6. So 6 squared minus 3 times 6. Is it equal to minus 4 times 6 plus 6? 6 squared. 36. 3 times 6. 18. 36 minus 18. 18. How about the right hand side? Negative 4 times 6. Negative 24 plus 6. Negative 18, right? Ooh, you see? That's not a solution. Therefore, our solutions are, okay? Yeah, so the solutions are x equals negative 3 and x equals 1. We get 2 solutions. So that finished the problem. Okay. This is how we solve equations involving absolute values. Put a line in the middle, do both, and then check the solutions. Okay. Oh, we only have 10 minutes. We're seriously behind schedule. Okay. Here we have the m fruit. Okay. So when we have m fruit, so for example, here let's solve the following: x squared equals 64. When you want to get x, so you want to carry out the 2, so you take square root on both sides. But when you take square root, you get plus or minus, right? Everybody, remember? You get plus or minus. So x is plus or minus square root of 64. What's square root of 64? 8. Okay, so this is part A. When you take square root, don't forget plus or minus. But if you take keywords, do you need to have plus or minus? No, exactly. So for the even roots, you need to do plus or minus. But for the odd roots, you don't need to do plus or minus. Okay, everybody? All right, how about this one? Ooh, x is plus or minus square root of negative 64. Can a number inside the square root be negative? No. In this case, no real solution. Right? Because the problem is find all real solutions. Sorry, we don't have any real solution. But we do have complex solution. Do you remember we say I? Yeah, I is square root of minus 1. Do you remember that? I is square root of minus 1. Therefore, negative 64 is like negative 1 times 64. We get square root of negative 1 is I, square root of 64 is 8. We have 2 complex solutions. Okay, how about key roots? So you take the key root, you don't get plus or minus, you just have key roots, positive key roots. What is key root of 64?
4.
Yes, very good. Yes, everybody? 4 times 4 is 16. 16 times 4 is 64. So 64 is 4 cubed. Okay. How about here? Negative 4. Exactly. So cube root of negative 4. Cube root. It's okay that the things inside the cube root is negative. It's okay. Then we just get negative. And then cube root of 64 is 4. So how we treated the even roots and the odd roots. All right, and then look at the following. Example 9. Find all real solutions of each equation. Okay, so our goal is to factor. Okay, our goal is to factor. I want to show you a wrong solution. And you tell me what is wrong with that. Okay, so I add 36x on both sides. I get x of fifth is 36x. And then at both sides divided by x. Then I get x to the fourth equals 36. Okay, and then I take the 4 roots. So then I get x is the 4th root of 36. And, this is the same as 36 to the 1 over 4. Right? The 4th root is 1 over 4. And 36 is 6 squared. So 6 squared to the 1 over 4 is like what? 6 to the 2 times 1 over 4, which is 1/2. So I get square root of 6. And I tell you this is a wrong solution. Can you tell me what are the mistakes? Yes, Very good. Whenever we divide by x, we are assuming x is not 0. But in this case, x equal to 0 is a solution. See, you plug in 0. 0 minus 0 is 0. 0 is a solution, but we cannot divide it by x. Excellent point. So let me use, okay, so this is wrong. One mistake is we can divide it by x because then we will lose the solution. X is 0. Okay, can you find another mistake? What do you do when you have 4 roots? You get what? Plus or minus, right? Everybody? You actually get plus or minus. So the second mistake is when you take the 4 roots, you actually need to get plus or minus. Yes, everybody? So what is the correct way to do that? Okay, don't move to the other side and then divide by x. Don't divide by x. Our goal is to factor. So factor. Do you see the common factor is x? Then we have x to the 4 minus 36. Yes, everybody? Factor it. Okay. Complete. Do you see this is like difference of a squared minus b squared is a plus b times a minus b. Do you see x squared? So x to the 4 is like x squared, and 36 is like 6 squared, right? So therefore, we can factor it as x squared plus 6 and x squared minus 6. Is that okay, everybody? We recognize A is like a squared, x squared. B is like 36. Okay, can we factor further? X squared plus 6, can you factor this one? You can do it. You recognize 6 is like square root of 6 squared. Yes, everybody? 6 is square root of 6 squared. Therefore, we get x plus square root of 6 and x minus square root of 6. So therefore, x give us x is 0. Oh, because you think about, okay, what number square is 6? Let me call this number is b, okay? Like b squared is 6. Then what is b? You take the square root of 6, you get the b. Yeah. Good point. And then this is x is negative square root of 6, and this gives us x is positive square root of 6. And by the way, if you cannot factor at this step, it's okay. You can set each factor equal to 0 here. X equal to 0 give us a solution. And then x squared plus 6, it cannot be 0, so it's impossible for this one. And then x squared minus 6 is 0. You can solve for x. You put x squared minus 6 is 0. X is 6. X is plus or minus 6. Square root of 6. You still have the same solution. So you don't have to factor here. You can do it from this end. Okay, everybody? Mm-hmm. Yes. Oh my goodness. Okay, we are seriously behind schedule. Do you mind I finish part B really quick? Okay, this one is easy one. So x plus 4 cubed. Isolate it. So move the 16 to the other side. It becomes negative. Right, everybody? And then we can take cube roots. Well, when we take cube root, do we get plus or minus? No. But we can move the negative to the outside. A cube root of 16 is not an integer. You know that, right? Yes. Okay, so just leave it like that. Then we add 4 on, subtract 4 on both sides to solve the x. So subtract 4 on both sides. We get x equals negative cube root of 16 minus 4. So this is the solution. Okay, so that is part B. Any questions? By the way, can I add the 16 and 4 and become the 20? Can I do that? No, this one has the cube roots. This one does not have the cube roots. We cannot combine. So see you on Friday. Okay. So we're gonna speed up. Okay. Thank you.
Oh, yeah.